Having your own custom control rig that you can use to change the posing of a character and animate them in things like cutscenes can be very, very useful, and it's just nice to be able to animate right in engine. Having forward kinematics and inverse kinematics, we're going to be looking at both of those today. We're going to be making a simplified version of this entire setup that I've got over here. There will be a link down below in the description to a clean project, which includes the model for this character here, that you can use to compare your own work to mine, or just to dive a little bit deeper into the entire system on your own pacing. Here we are in the empty project, and I've imported my skeletal mesh here. I'm not going to be bothering including all the textures and stuff. That's not what's important here right now. What is important is that we have a skeletal mesh, and we can look at that. And just as you expect, we have a hip bone, some thighs, shin, foot. It's a pretty simple skeleton with not a lot of deformation, and more so on a joint-based system. We're also not going to be bothering with the fingers today, because that could be a video in and of itself. What we'll do is we'll click on the skeletal mesh with the right mouse button, and then we can create from that down here a control rig. And that automatically takes the same name as the armor here, but just adds control rig as a suffix. Let's open that up and see what we got here. So we have a blueprint-like graph, but instead we can't like get player character or anything here, because this is not actually a blueprint as you know it. This is a control rig graph. And we can do a lot of different things in here. This can be very complicated, and you can make this as complicated as you would like. But for now, we're going to go up here to the rig hierarchy, and that gets us, again, all of the bones in our model. I'm going to collapse that for the time being, and we'll make a simple new controller. And we'll name this controller something like root. And we'll see that that adds this little red circle here. So that's not really what I want for my root. What I want instead is when I select this root, we can see in the shape properties here, we can choose from a lot of different shapes. So what I used myself was, I think, something like a thick square. And I think I made it blue before. Let's make it purple. It doesn't really matter what color you make it. And from there, we can scale up specifically only the shape. So we can make that a fair bit bigger. Let's actually just make them 10 times bigger in all directions. Maybe 15 times. 15 times seems about right. So that will be our reference for where the root is. So if we want to animate anything about this character, we know that this is its original position. This root itself should not ever be allowed to move though. Ever. At all. So if we extend this a little bit, you might not see it at first, but if we extend it, we see a minimum and a maximum transform for this component. So in every single one of these, we're just going to simply turn these on. And that will now prevent us from moving, rotating, or scaling this thing in any way, shape, or form. So we can see it's actually not allowing us to move. And that's a good thing in this situation. Because if we want to move the character as a whole, we're going to make a separate controller for that. So we're going to right-click on our original controller, make a new controller again. You can also use the Ctrl-N shortcut. And for that, we're going to, I like using a triangle here, rounded triangle thick. Make it, I don't know, about twice as big. That seems about right. And rotate it 180 degrees around the Z. That way it's facing in the same way as our forward direction here. This one, we can actually move around all we like. And that's where our first actual rigging bit comes in. So let's call this one character movement, something like that. And we're going to parent the whole skeleton to this little controller over here. So the whole skeleton comes all from the hips root bone. In your own skeleton, you might have a separate root bone from the hips. That is actually recommended to do. I didn't do that because I'm stupid. But usually you would have a root bone down here that's separate from the hips. And now we're going to add our first actual node. So that'll be a parent constraint node. And we'll just plug that in as we do with any blueprint. And we'll select a child, which is of type bone. And we'll use the bone that we have selected right now, which is the hips. And then in the parents, we can expand this, and the first item, the type will be changed to a controller in our case, and that will become our character movement. So now if we move the character movement around, you can see it changes the position for the entire character. Good to know though, is if you compile at any point, it resets back to its default position for everything. So don't worry about putting things in weird positions, just compile things and they will all reset. And that's the first little bit we've done for rigging. So congratulations, that's the first step. Now we're gonna get into the actually interesting stuff, because we want to make a chain of forward kinematics to deal with everything to do with like the torso and the hips here. So first things first, we're going to expand the hips and we're going to stop the expansion at the thighs and the upper arms. We're not going to use those. And what we'll do instead is we'll select the hips all the way up to the head in this case, and right click, new, add controls for selectors. And that adds some very big controls. We'll deal with that in a moment. But as you can see, it has the same hierarchy here already. Let's select all of those and make those a fun color. I think I had them yellow in my own rig. And we'll scale them down a fair bit, but not before changing them into a circle thick. And they're oriented the wrong way around, and we'll fix all that in a moment. So we can try to rotate these, I think in the X 90 degrees, that'll work. That works perfectly. And then make them about 10% the size that they are now in all axes. That's a little too small actually, so let's make them about 20% the size. That seems about right. You can individually now make them a little bit smaller where they need to be, so they fit a little bit more snugly around the model. That's entirely just for your own preference and your own like visual input. It doesn't actually change around anything to do with the rig itself. I do like making the color for the head controller though a different color from the rest of the body. So let's put this one on a blue color. That seems about right. Now, these things, of course, still aren't connected to anything, but they are connected to each other, as you can see. So this already really, this parent-child relationship is what forward kinematics does. But we just need to tell these controllers to influence certain bones in the skeleton. And we can do that with a FK chain. That requires us to get an array of the bones and an array of the controllers that we're going to be using. So it's relatively easy. Just select all of the bones that should be in the array. And then we can simply just drag it into the event graph here. And we can create item array. Simply as that. That's the array for the bones. And we can do the same thing with the controllers. Create item array. And that will be the array for the controllers. And with that now, if we change this, of course, you probably don't want to actually change the hip bone in this case, because again, I was stupid and I made the hip bone the root bone as well. You want a separate root bone. But if we look at, for instance, the waist, we can change that now, and it changes the actual bones corresponding to this very, very nicely with that. But now it seems like I actually forgot one of the bones, because we have hips, waist, stomach, chest. I forgot to add the head, so we can add an array element here. We can simply say we want to add a bone, and that bone should be our head bone. And that is the forward kinematics. It's an FK chain. Now what we're going to do is inverse kinematics. And we're going to do that for the legs here. So let's take a look at how we do that. Just for sake of ordering things, what I like to do is I want to have this parent constraint here at the beginning, and then I want to have a sequence node. This is not entirely necessary. This doesn't like actually do anything. It's just to make things easier to order. So it first does the FK here, and then we'll move on to the IK. And for that, we're going to use IK2 bone. We also have an IK3 bone. If you have a longer IK chain, you will use that, of course. But for now, we'll do a IK2 bone. So as we're going to be adding about 4 different limbs here, it's a good idea to actually make sure we organize everything properly. So let's take a look at our left thigh here. And at that location, we're going to create a new null. This is just a folder, you could think of it, in which we can put other controllers. So let's call this leg_capital L and put that under our character movement controller. As a matter of fact, let's also get the hips controller in here and parent it to the character movement. That way it will also move when we move this, because if we don't do that, I'll just Ctrl Z through that a little bit. It does nothing because the hip bone and stuff like that is now controlled through the other controllers. So we want to move those controllers when we move the entire character as well. Now that we have this leg L null, which again, it's just kind of like a folder, what we want to do is we want to add two new controllers. We're going to add a controller for the knee and a controller for the foot. So let's go into our shin and our foot, starting with the foot, adding a new controller. I'm going to make this one, I think, a circle. Let's do a solid circle for this one. Rotate it 90 degrees in the X and make it a bunch smaller. And it's really annoying that the scale here is not automatically set to being locked in. So that's the first controller. And then we'll also make a controller from the shin position. In my case, it's called the shin bone. You can call it really anything you want to call it, as long as it's created at wherever the knee is. And this one will actually pull out a little bit, because this is what the knee is going to be pointing towards. So we're going to use this one to put the position of the foot in, and then this one is going to be the pull target for where the knee will be pointing. We'll parent the shin controller here, or the knee controller rather, to the foot itself. So if we move the foot, the shin will move with it. And you can see, okay, that is kind of an issue, right? Because we changed this thing around, and the moment we made any other change, or when we compile this, as you can see, it will snap back to where it started. So this is where we get the initial, current, and offset transforms. We'll see if we highlight the current transform and we change this thing around, it changes around here. And this is the transform that gets reset every time we compile. So what we can do is we can right click on our controller here, and we can set offset transform from current. And that will reset the current to being all zeros, and then just set the offset to being that. And now if we recompile, it stays in that position. Now, change the foot controller to our leg null, so that it's all nicely organized. And now we can start implementing these things into the actual IK2 bone node, which looks very complicated and very scary, but it's not that bad. So first and foremost, we have the pole vector, which is the thing that the joint is going to be pointing towards. So we put that in there. And then we have the end controller all the way down here. That's going to be the controller that controls the position of the foot. We put that in down there. And then we have bone A, bone B, and bone C. And that is literally as easy as just the first bone in the chain is bone A. The second bone in the chain is bone B, and the third bone in the chain is bone C. And the moment you put that in, things will absolutely break apart. In my case, these pieces are all over the place, and that's because these pieces of the mesh are entirely separate and parented to the bone. In your case, it might do some weird deformation. But the reason that is because we have this primary and this secondary axis set up. And I'm going to disconnect this for a second because we want to be able to look at what way the bones are facing. So here we have the primary axis and the secondary axis. The primary axis is more or less just the axis in its local space, which points up. And the secondary axis is the forward direction. So what we want to check here is in the thigh, we want to right click and control bone transform to see this little gizmo pop up. And we see the green arrow pointing up. So that means that the Y is pointing up. So what we want to do, we want the inverse of whatever this is. So if Y is pointing up, what we want is a -1 in the Y. Then the secondary is the forward axis for your foot bone, generally speaking. And that will be control bone information. Yeah, so that will be Z in the positive. And now if we connect this back up, we'll see that it doesn't glitch out anymore. And we actually have our inverse kinematics just simply set up now. We can put the foot over here, and if we move this around, we can see that it bends the knee to be looking always at this pull target over here. And just because I'm annoyed here that it's not entirely spherical, I'm going to fix that real quick. And that is inverse kinematics also set up. So we want to do the same thing for the other leg as well, right? Because of course, we want inverse kinematics for both legs. So if we select all the controllers to do with the left leg here, and we right click, we can mirror. The mirror axis will be the X, I'm pretty sure, because we have the X going into this way. And then the axis to flip will keep at none. And then we're going to be searching for a certain piece of text, which is going to be _L. That's why we're labeling everything properly. And then we're going to replace that with _R, because everything is being put on the right side now. And if we click OK, we can see we have an entire setup for that immediately as well. And we can do the same thing with this node, actually. We can just copy that over, and we can right click, and we can search and replace /mirror. I'm pretty sure we do want the axis to flip here. I always forget. And we'll search for everything that's on the left, and we'll replace it with everything being on the right. And now, as easily as that, we should be able to also use this on inverse kinematics. And as promised before, now when we change this, the legs won't change because the IK takes priority over the FK here, because it's being applied after it. So, as a little bit of a challenge for you, I want to challenge you to do the same thing with either just your own model, or if you're using my project files, which again, link down below in the description to the Patreon, doing the arms, because they work the exact same way. They have a shoulder bone, or an upper arm bone, a lower arm bone, and a hand bone. What you'll do is on the elbow here, you'll make one of these controllers. On the hand, you'll make the other controller, and you just copy this setup with the different controllers. And maybe you need to do something different with the axes. Who knows? It's a little bit of experimentation needed sometimes to make things work. But in general, this is how you make a control rig in Unreal Engine, which allows you to animate for either cutscenes or gameplay animations as well in Engine itself. And the way we can do that, I'll show you real quick, is now that we have this control rig, we can just put this into the world somewhere, and that immediately opens up the sequence. So I always have it on a separate monitor because it's easier for animation. But we can start animating this. So if we want to do control rig, just keyframe everything, go to frame 30, and maybe we want to make a walk cycle, so we do that. And this one maybe goes back a little bit, and then these go down ever so slightly. Make a new keyframe for all that. That interpolates. It's a very bad animation, but just stick with me here. Once your animation is done, you can right click on the control rig, and we can create a linked animation sequence. Or you can just bake it into an animation sequence if you prefer that. I like creating a linked one, because that way if we go back to this sequence animation and change something, it immediately changes in the animation sequence as well. So we can just create that as we'd like. And now we have this animation sequence here, which we can use in pretty much anything that we want to use an animation in, usually. You can use this in your animation blueprint or whatever. You can even export this asset as animation data, and it'll allow you to export this animation as a FBX, which is very, very nice. So even if you're using Unreal and another engine as well, and you're used to this workflow at some point, rather than animating in Blender, animating everything in Unreal, you can still just export this and use it in like Godot or Unity or whatever you want to do. But as you can see, this animation is much longer than the actual animated part, and that is because I didn't put this end of animation line where it should be. And just to show you, let's put that line over here and create a new keyframe as well. And I don't know, just like turn the upper body around a little bit and maybe make this foot follow that ever so slightly. And now, without doing anything else, we can save this animation sequence, and then going back to this animation here, we can see immediately that new animation bit has been added to it, and everything after it that we had left over before is also now cut off. So there's a very good and dynamic way to create animations within your own game. So thank you very much for watching all this, and next time maybe we'll have the arms already done. I'll probably do that off screen, and I'll make a separate video about rigging the hands, because it's a little bit more finicky and this video is long enough as it is. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thank you to Eleanor for supporting at the Cave Digger tier on Patreon.